All right, welcome to section 6.3. The first thing we're going to do is we're going to review the rules of exponent from like algebra 1 and algebra 2. So the first rule I always talk about is x to the second power times x to the third power. When you multiply like bases, you always add the exponent. So it's x to the fifth. So I call that the addition rule. The opposite of addition is subtraction, right? So subtraction. So the opposite would be to divide. So x to the fifth divided by x squared is equal to x to the third. So when you divide like bases, you subtract the exponents. Number 3, when you have a power raised to another power, you always multiply the exponent. So it's x to the sixth. That's the multiply rule. Multiply. Rule 4, anything to the 0 power is 1. So I call this the one and done rule. Rule number 5 is negative exponents. Negative exponents mean fraction. They don't mean negative number. So it's 1 over x squared. So I say cross the line and change the sign. Fraction line, it changes the sign. And number 6, if you have the same exponent, and you multiply those together, you can also do it this way. You could multiply the bases and then make it one exponent, because x is being cubed and y is being cubed. So these are the 6 rules of exponents. So this one has to do with how exponents are distributed. This also works with division. If you have x to the third over y to the third, you could call this x over y to the third, because you cubed the top and the bottom of the fraction. Okay, now we're going to think about graphing. Graphing is graphing these exponential functions. So if we put in different numbers, put in -1, we get 1/2. So if you put in negative numbers, it becomes fraction-y because you cross the line, change the sign, and then put in 0, you get the first, 1 goes in, you get 2, 2 goes in, you get 4, 3 goes in, and you get 8, right? So this is the basic graph of an exponential 2 to the x function. So what would happen if I did this? Y equals 2 to the negative x. What's that going to do to the function? Well, remember, when you take out x and put in negative x, you're switching x and negative x. That's a left-right switch, so it's going to go over the y-axis. So this is a y-axis flip. If you put a negative in front, it always does the same thing no matter what the function. So you're replacing negative y with y or vice versa. So that's an x-axis flip. Okay, we can also move functions up and down. So y is equal to 2x plus 5. That moves the function up. If it was a minus, it would move it down. So we go up 5. If we want to move the function left or right, we have to put a number inside the x in parentheses. So it's 2x plus 2, right? So if there's a 2 up there in parentheses before you do the exponent, that's going to move it left 2. If it was minus, it would be right 2. So in the book problems, there's matching, where you have the original function and then all of these things happen and you have to match it up, how it flips it over left, right, shifting up, down, etc., etc. Then the second part of the assignment is solving equations. So to solve equations like this is a more complicated one. The first one in the book is really straightforward. But to solve these equations, what you want to do is you want to make the bases the same. So 9 is 3 squared. That matches that base there, to the 2x, times 3 is cubed to make 27, and that's to the power of x squared, is equal to 3 to the negative 1. Now all the bases are the same. Then we had the rule. When you have an exponent raised to an exponent, you multiply the exponents. So this becomes 3 to the 4x times 3, and then you multiply those together. 3x squared is equal to 3 to the negative 1. Then we can use rule 1. When you have same, right? When you have same bases and you multiply, you add the exponents. So this becomes 3 to the 3x squared plus 4x is equal to 3 to the negative 1. Then our mantra for this section is, if the bases are the same, right, the bases are the same, then the exponents are the same. So now I can set the exponents equal to each other, and I can say that 3x squared plus 4x equals -1. All right, so this is a quadratic, so we have this complicated equation here, and it reduces down to a quadratic, which is why I've been asking you guys to keep solving quadratics over and over again. So to solve a quadratic, we set it equal to 0, so I'm going to move over the 1, make it +1 equals 0. Then I'm going to factor my quadratic, so I get 3x and x, 1 and 1. And there's really no choice with this because well, 1 times 1 is the only way to make 1, and 3 is prime, so plus and plus. Then we do 0 product proper t. 3x plus 1 is equal to 0, x plus 1 is equal to 0. So x is -1, subtract 1, 3x is -1, x is equal to -1/3. So that's the two answers for this one. So the problems in the book look like this. This is section 6.3, and here's how the problems look in the book. So I'm turning to section 6.3, and the first section is this matching section. So you have these problems here, and you got to match the equation to the graph. Then I asked you to do these solving equations. So starting on number 63, then you're solving these equations here. So the first one you have to solve is really easy because the bases are already the same. So to do number 63, you say 7 to the I don't know power is equal to 7 to the third. Well, if the bases are the same, then the exponents are the same. All right, so if the bases are the same, the exponents are the same. So x is just 3. You're done. 65. 65 is 2 to the -x is equal to 16. This is an exemplary problem. We got to make the bases the same. Well, 2 and with a whole bunch of 2's makes 16. So 2 to the -x is equal to 2 to the 4th. So since the bases are the same, then the exponents are the same. So -x is equal to 4. You are not done solving until you know what x equals. So x is equal to -4. All right, so you got to divide the negative over. 67 is 1/5 to the x power is equal to 1 over 25. Again, make the bases the same. So 1/5 to the x is equal to 1/5 quantity squared. So squaring makes that. So this one just matches up perfectly. X is equal to 2, and then you're done. 69. 69 is 2 to the 2x minus 1. Is that what it said? 2 to the 2x minus equals 4. Okay, so we're going to make the bases the same. So it's 2 to the 2x minus 1 is equal to 2 to the 2 power. So the exponents are the same. So now you have to solve 2x minus 1 is equal to 2. Add the 1 over. 2x is equal to 3. X is equal to 3/2. So that's how you do those. The assignment is on the Google Classroom. So you're matching and you're solving these equations. Ta-da!